Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to solve a last numerical of state space analysis, that is a problem number 13. Now in this question we are going to find out both the things like controllability as well as observability. So first of all we'll see the question, what is given in that and how to find out a controllability and observability. Problem number 13. A transfer function of a system is given by y of s by u of s equals to 2 upon s cube plus 6s square plus 11s plus 6. This is our equation, or you can say transfer function. But by using transfer function we have to find out first of all the state equation, because using state equation you will get the matrices values, that is A matrix value, B matrix value and C matrix value. Now what is asked in question? Test the controllability and the observability of the system, which means using that matrices we can get the values of controllability and the observability. So first of all we'll convert whole transfer function into our state equation. This is our transfer function. Now what we want, we have to convert this transfer function into state equation, because in a state equation we will get the values of A, B and C matrix. So first of all what I'm going to do, I just cross multiply s cube s6s square plus 11s plus 6 will multiply y of s, and the 2 is multiplied with u of s. Now just multiply y of s inside this bracket. Now just apply inverse Laplace transform on both the sides. S cube into y of s. The inverse Laplace transform of s cube into y of s is, we can write, it is a 3 times differentiation of y of t, or a third order differentiation of y of t. We can write this third order differentiation of y of t like y 3 dot of t. Here the 6 is constant. Now here we have s square. So if we apply inverse Laplace transform on it, s square y of s is represented in time domain by double order or second order differentiation of y of t. So we can write double y dash of y of t. Now here we have s into y of s, which means we have the single order differentiation of y of t. So we can write y dash or y dot of t. Next, here we have 6y of s, which means we'll write 6y of t and equals to 2u of t. Now what to do? We will going to assign a state variables. Here the total highest value of differential equation is 3, which means we can choose a 3 state variables. So as I said, here we have a third order differential equation, which means we can use the 3 state variables. And let's say the state variables are x1 of t, x2 of t and x3 of t. Now we will substitute all my state variable values in my equation. Now we are going to substitute our state variable values in left hand side. On left hand side we'll substitute our state variable values, but we will start with y of t. So let y of t is equals to x1 of t. Now we will differentiate both the sides, but we can differentiate state variable max to max up to 1. So we will replace, or we can substitute the next state variable value in front of x1 dash of t, which is x2 of t. So if we want to differentiate this equation once again, so we are not going to differentiate x1 of t, because x1 of t is already differentiated up to its maximum value, that is 1. So we'll directly differentiate x2 of t. So y double dash of t is represented by x2 dash of t. As I said, we can differentiate our state variable max to max up to 1. Now this one is the highest limit of x2 dash of t. So we'll replace it by x3 of t. And now if we differentiate it up to third order, then you will get x3 dash of t. Now just do one thing, we'll write the equation for y triple dash of t, which means we can shift all these three values on right hand side. Now, what I'm going to do, I'm going to replace all these equations by state variable. But we know that on left hand side, we will always place a differential values of state variable. But on right hand side, we will always place a normal values of state variable. So the differential values of y triple dash of t, which is represented by x dash of t. So we'll write x3 dash of t to u of t. Now, 6 y double dash of t is represented by simple state variable, and it is nothing but my x3 of t. Next, y dash of t is represented by x2 of t, so we'll write, and y of t is represented by x1 of t. And from this equation, or from this whole solution, we can write the equation of state variable model. So this is our state variable model. Now we have to find out x1 of t, x2 of t, and x3 of t values, as well as u of t values in my x1 dash of t equation, x2 dash of t equation, and x3 dash of t equation. So first of all, we'll find out all these four values in my x1 dash of t equation. Now where you will get x1 dash of t equation, you will get that value or that equation over here. Here we have only x2 of t in my x1 dash of t equation. So we'll substitute only x2 dash of t value, that is 1, in our first row. As I said, you will get only x2 of t value in x1 dash of t equation. So we'll write 0 and 0 because the coefficient of x2 of t is 1. Now similarly, we'll find out x1 of t, x2 of t, x3 of t, and u of t value in my x2 dash of t equation. Here we have a 0 value in u of t. Now in my x2 dash of t, we have only x3 of t. So x1, x2, and u of t all are missing. So we'll mark coefficient of x3 of t value in my matrix. Now we'll find out the same thing but in x3 dash of t equation. We have to find out x1, x2, x3, and u of t value in x3 dash of t equation. But where is my x3 dash of t equation? The x3 dash of t equation is over here. Here my x1 of t value is -6, x2 of t value is -11, and x3 of t value is -6, and here my u of t value is 2. So we'll write -6, -11, -6, and 2 in u of t column. And this is my input state equation or input state variable model. Similarly, we'll find out the output state variable model. Now we have to find out all the state variable values as well as u of t value in my y of t equation. Look at here, this is my whole substitution, and in this substitution we have only y of t value over here, or equation over here, and here we have only x1 of t value, which means all the x2, x3, and u of t values are replaced by 0, and x1 of t value is replaced by its coefficient, that is 1. And this one is my state variable model. Now I'll compare this whole state variable model with my standard state variable equation. Now just compare all the matrix. So here my A matrix is this one is my B, next one is my C, and D value is 0. Now what I'm going to do, I'll find out first of all the given question is controllable or not, which means we have to find out a QC matrix in which we required only A matrix and B matrix, and later on we'll start calculate the observability of system where we required only A transpose and C transpose matrix. Now we have calculated A matrix, B matrix, C matrix values as well as D. Now we are going to substitute all these values or matrix but in QC and Q just to check whether the given function is controllable or observable or not. Now, how to check the controllability? So there is one formula that we have studied in last numerical also. QC is equals to, well, here we are going to substitute all the values but in column wise. Basically, this is the column which is of B. Now, then we'll multiply A and B and you will get the answer in single column. Similarly, we are going to multiply B with A square. Again, you will get the answer in single column. So, you have to do till A to the power n minus 1. Basically, n minus 1 means what? We have to find out the highest power of A. So that just we have to find out a controllability, right? Now, in controllability, we want to write the answer in columns. So, how many columns we required to get the answer? So, here the highest value of A matrix is n minus 1. But what is n? N is the number of rows and columns present in A matrix, or else the number of state variables present in question. Now, if you go through the answer, then in the last page, we have calculated our A matrix and the columns and rows total is 3. The value of rows and columns in A matrix is 3. So, I can say that my n value is 3. If my n value is 3, then n minus 1 is 2. Means what? We have to calculate our column matrices up to A square B, and it is started from B. Here my A power is 0. Basically, our A value having a power 0, which means here we can write A into B. But in this case, in formula, our A power started from 0. The next value is having power 1 and next value is power 2. And we are going to calculate up to A square into B. So first of all, we will write A matrix and B matrix. The first column is of B. So we can directly substitute my first column is 0, 0, 2. But next column is filled by just multiplying A with B. So just we'll multiply A with B. We have studied one thing. We are going to multiply these two columns. But basically, if you want to write the answer, then we will always write the answer in column. But how many rows and how many columns will be there? So as I told you in last numerical also, this numerical or this matrix is of 3 by 3 matrix, that is 3 columns and 3 rows we have, and here we have 3 rows but in single column. Now just multiply all elements. Like this you are going to multiply, and now just cancel adjacent values, that is these 3 and these 3 will get cancelled. So what else is remaining? This 3 by 3, in this 3 by 3, this 3 represents 0, and in 3 cross 1 this will represent the column, which means you have to write the answer but in 3 rows and single columns, or else you will get the answer in 3 rows and single column. Now, so just do the cross multiplication. 0 into 0 is 0, plus 1 into 0 is 0, and the last one 0 into 2 is again 0. So we have a first value, that is first column value is 0. Now we'll move on to next. We'll multiply second column with the same row. So 0 into 0 is 0, 0 into 0 is 0, and 1 into 2 is 2. So what you will get? This. And after adding all the values, you will have answer a 2. Now again do the same thing. 0 into 6 is 0, minus 1 into 0 is 0, but minus 6 into 2 is minus 12. So we can write, and our far answer is 0, 2 and 12. So this is the matrix of AB. So this whole column is placed in over here, and this B matrix column is placed over here. Now we will find out A square B. Now what we want? We want to find out A square into B. Now A square means we have to find out the square of this A matrix. So what will be the square? You can use the calculator also, or else simply you can do the multiplication of two A matrix. Means if A is multiplied with A, then answer is A square. Means multiply the same matrix with itself, and then whatever result will be there, just multiply it with the B. I'm going to use a calculator so that you will directly get the answer. So I'm going to write the answer of this squared matrix, that is A square. So the square of A is 0, 0, 1, minus 6, minus 11, minus 6, and 36, 60, and 25. Now again, what we are going to do, we will multiply this whole row with a single column. Then you will get the first element of first column and row. So 0 into 0 is 0, plus 0 into 0 is 0, plus 1 into 2 is 2. So answer is 2. Next, minus 6 into 0 is 0, minus 11 into 0 is 0, but minus 6 into 2 is minus 12. And again, 36 into 0 is 0, plus 60 into 0 is 0, but 25 into 2 is 50. So this is our A square B matrix. Now we will substitute all the B, A, B and A square B matrix in my QC matrix. So I have substituted my B matrix, AB matrix and A square B matrix in my QC, and this will nothing but my QC matrix. Now what we have to do, we are going to find out the determinant of QC. Now we know that 0 is multiplied with 2 into 50, minus 12 into minus 12 will be subtracted from 2 into 50, but there is no use of it because we are going to multiply it by 0. So the first element value is 0. Again, this one is also having a first value 0, and after that you are going to multiply 0 into 50 and it will be subtracted. The minus 12 into 2 is subtracted from 0 into 50, but there is no use because we are at the end, the whole product is multiplied with 0, so answer is 0. Now the second element, that is last 2. Here 0 into minus 12, answer is 0, minus 2 into 2 is 4, so we'll write here 4. So what is remaining? 0 plus 0 plus 2 into minus 4, answer is minus 8. So this is the value of QC. Now here we are going to check the two states. The first one is a rank. Here the rank is always equal to state of matrix or the state variables. Now here we use the 3 state variables and my rank is also 3. So I can say that the function is completely controllable. But so one more thing we have to see, that is QC. If the QC value is not equals to 0, then also you can say that the function is controllable. So therefore I can say that here QC is not equal to 0 and rank of QC is 3. So therefore my system is completely or absolutely controllable. Now the next part is observability. This function is controllable. Now we'll see whether this function is observable or not. Now we will see whether this given question is observable or not. Now there is a formula to check the observability, which is Q naught is equals to, or QO is equals to, O stands for observability. Here C transpose gives the first column of matrix, A transpose C transpose gives the second column. Similarly, this will gives us the next all columns. But how many columns we want or will be there to check the observability of the system? So we will substitute my n value. Basically my n value is nothing but the number of state variables present in question, or else you can say that the number of rows and columns present in question. Now in this question my state variables are also 3, as well as the rows and columns in A matrix is also 3. So I can say that my n value is 3. And if my n value is 3, then this n is replaced by 3. So 3 minus 1 is 2. So what I can say that you have to find out the columns up to A to T CT. So this formula is updated. C transpose is my first matrix. So Q naught is updated as C transpose gives us my first column. A transpose C transpose gives us second column, and A transpose square and multiplied with C transpose gives us a third column, and then you will get the answer of Q naught, or you can say the whole matrix of Q naught. So first of all, we'll write the transpose values of A and C. So this is our C transpose and A transpose. First column you will get from directly C transpose equation or the matrix, but second column for the second column, but for the second column you have to multiply A transpose with a C transpose. So we'll first of all we'll find out the product of A transpose and C transpose. Now, what will be the answer of this product? Simply, the first row element is multiplied with first column, but each and every element product is added with the next element product. So 0 into 1 is 0, plus 0 into 0 is 0, plus minus 6 into 0 is 0. So you will get 0 as the first element. Now we'll do the same thing. 1 into 1 is 1, plus 0 into 0 is 0, plus minus 11 into 0 is 0. So you will get only 1 as a second element of row. Last, 0 into 1 is 0, 1 into 0 is 0, minus 6 into 0 is 0. So you will get 0 at the end. And this is the value of my A transpose and C transpose. Now we will find out the third matrix column, or the third column of the matrix, which is A transpose whole square, which is multiplied with C transpose. Now we have to find out the third element of Q naught matrix, or third column of Q naught matrix, and it is obtained by just multiplying AT the whole square, that is A transpose whole square, into C transpose. So first of all we will write the matrix of A transpose. And we have to take the square of it, and then it is multiplied with our C matrix, which is, now we will find out the square of this matrix. Look at here. So this is nothing but my square of A transpose, and it is multiplied with my C transpose value or matrix. So just do one thing, multiply row with column, but while multiplying, first element is multiplied and then the result of it is added with a second term, or the second multiplication, and so on. So first of all, 0 into 1 is 0, plus minus 6 into 0 is 0, minus 36 into 0 is 0. So I can write 0 plus 0 plus 0. This will be my first element. Now we'll move on to next. 0 into 1 is 0, minus 11 into 0 is 0, 60 into 0, answer is 0. Now in the last, 1 into 1 is 1, plus minus 6 into 0 is 0, 25 into 0 is 0, so answer is only 1. And this is nothing but the result of A transpose whole square into C transpose. Now we will substitute all the values in my Q naught matrix. Now we have substituted the values of C transpose, A transpose C transpose, and A transpose square C transpose. Now first of all, what will be the rank of this Q naught matrix? Of course, here we have a 3 non-zero rows, which means rank of Q naught matrix is 3. Now we will find out the determinant. So how to calculate determinant? Of course, 1 is multiplied with product of this minus product of this. Answer is 1 minus. Here we have a 0, so we'll write 0, because 0 into anything is answer is 0. So no need to find out the 0 is multiplied with these two values and these two values. But as the 0 is going to multiply, so answer will remain 0. So we'll write only plus 0. So what you will get, answer is 1 into 1 is 1, and it is not equals to 0 basically. So using these two conditions, I can say that the given system is completely observable. This is how we can calculate the controllability and the observability. So thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.